Well, hello everybody, this is Dr. Jeff of All Trades here again. So we are looking at a small kegerator that needed some repair today. The story behind this is I took a load of aluminum and steel to the scrapyard and made a whole $1.50 off of it. It wasn't very much, obviously. And I saw that somebody had dumped this thing out in front of the scrapyard overnight. And so I asked them, I said, hey, do y'all have the licenses y'all need to deal with the refrigerant and everything in these appliances? And they said no. I said, cool, well, can I haul this off for you then, get it out of your hair? Because I do. And they said, well, we try to go sell them to the appliance shop. And I said, well, I'll tell you what, I'll give you $1.50 for it. We all got a good laugh out of that, but they agreed and gave it to me, and I brought it home. So when I brought it home, I was like, let me just, probably it's not going to work, but let me just turn it on and see. Maybe it's low on refrigerant. Maybe it is, if I just charge it up a little bit, it'll start working, and then I can find a leak and, keep this thing going for a long period of time. So I ordered some refrigerant. This uses 600A, which is isobutane. It's not something I had. So, I spent $40 or so on Amazon and had some shipped to my house, got it in. Added a little bit of refrigerant. Compressor still didn't kick on. So I figured it must be electrical. I tested the voltage and everything. Here's the little thermostat. So we've got the line coming in here, and we got power going to some electronics here, coming back to the thermostat. So I had voltage and everything. And so let's take a look at the parts that were broken. So we're gonna come right over here. Now first, this little fella came originally with this little black wire attached right over here. And this is a a compressor overheat thermistor of some kind. So the idea is when it gets too hot, it triggers a little disc to short the power to, I believe, not to ground, but it basically opens the circuit and cuts power so that the thermostat doesn't work. And so when I took it out, I tested it for continuity between the terminal here and the other wire. No continuity, shook it around, it rattled. And it turned out that this thing was sort of blown up inside. I popped the cap off, and inside was this little thermal disc here. And if you look carefully, you'll see down toward the bottom, there is a chunk blown out of it. If I flip it over, the whole terminal contact button and everything was blown out. It was rattling around inside of there. So I said, this thing took a lightning bolt, all right? This got a power surge. The little resistor coil in there is fine. Okay, so I bypassed this, known as just a protection circuit, and I heard the motor hum, but it didn't start. So that led me to this. This is what they call a PTC coil. Right, PTC stands for positive temperature coefficient, and basically what this does is it temporarily routes the current to the starter winding of the compressor motor to get it started, and then it heats up and basically goes to infinite resistance, so that we disconnect the starter winding and just the run winding gets power. So we have a line coming in here, and so this top terminal, right, has power coming into the common winding here, and then we have the motor winding over here and the start winding over here. And so we apply our other leg of power to one of these terminals here, and that connects it to the motor winding. And then again, for a few seconds after this power's on, it allows power to cross over to this terminal, which is connected to the start winding, and powers up the compressor. And then once it's running, right, that heats up and disconnects, and then just keeps power on this side so the motor can run. I tested resistance across these two terminals, and it was in the 11 kilo ohms resistance, which I knew was not right for one when it was cold. So I took it apart. I pulled the little disc out, and in fact, if you'll bear with me for just a moment, I can do that again very quickly, assuming I can find my tool. Let me pop the back off, get the needle nose plier. If we look carefully in here, you may see that this side looks pretty good, that side looks like it's been smoked to hell. And indeed, that is what I found. Let me see if I can yank this coil out real quick, or this disc. My little needle nose pliers are somewhere else. I'm trying to fall. I really should just bring a tripod out here. So this is, where are we? Here we go, framing. This is a PTC disc, and it's made out of a material that basically increases in resistance as it gets hot. You can see that's smoked out. I polished it up with a sharpening stone a little bit and got it back down to about 8 ohms of resistance, which is somewhere in the range where it's supposed to be. You can see here, looks like hell, doesn't look too bad. I plugged it all back in. I saw a ball of plasma inside the little box, and the compressor motors tried to start, but then the resistance went back up and it failed. So I used the numbers on the side of the part and searched for a replacement. Couldn't find it. I'm not a whiz at finding parts, but on Amazon they did have some replacement thermal overload protectors and PTC relays. I called a local parts house in town, and they happen to have something that doesn't look quite the same, but electrically it does the same thing. So you can see the little rounded part right there, right? That has one of those PTC discs in, and it has the little terminals connected to the compressor. And then a completely separate piece up a little higher right here is a version of this little guy. It's just mounted in a slightly different location. So if that gets too hot, a little disc in there will pop and it will open the circuit and prevent it from conducting electricity. So I powered it up and it started up, and then it immediately shut back off again. So that was a problem. Now remember that I had added a little bit of refrigerant to this circuit, and I was like, well, let's check and see what's going on. So handy dandy amp clamp. We're gonna just pop that over one of the legs here, and I looked at that and it was pulling like 6 amps. Well, 6 amps is an awful lot compared to the rating up here, which reads 1.2. And so I figured I had overpressured the system. This thing only takes, I think, 0.95 ounces of refrigerant. It's a very small charge. And so with that in mind, I recovered the excess refrigerant, and got it down to where after about 5 minutes of running, it was running at 1.2 amps. It's been running for about 20 minutes now, and it's still running at about 1.15. I have the tiniest little bit of frost here, so I may add just a touch more refrigerant here in just a second, but it is cooling on the inside and everything seems to be working. I've been yapping at you for a long time. Yeah, so without recovering the whole system and pulling a vacuum and then recharging it with a scale, I am ashamed to admit I do not have a refrigerant scale that will measure in the fractions of an ounce, or a refrigerant scale at all. I just kind of used the known specs to put the appropriate load on the compressor, and there I know the charge is close. And I know it's close because that's cold as anything, not quite freezing up the line all the way down. It's been frosting up a little bit and then evaporating, then frosting up a little bit and then evaporating, which might suggest the charge is just a little low. So again, I'm going to keep an eye on it, let it run and cool to the point where it turns off using the thermostat, and then I'll assess the amp draw on the compressor and the defrost situation here and see what's going on. We're seeing it begin to frost up a little bit. So this little compressor, it has an internal overload protection. So thankfully when I had it overfilled and it was working too hard to compress, it shut itself off, and I just had to wait for it to cool down and for the internal protection to reset and recover some refrigerant and try again. So anyway, this has already been 12 whole minutes of me yapping at you, but if I had ordered these parts on Amazon, I could have gotten these for less than $10 and fixed this electrical issue for less than $10. I could have avoided putting this piercing probe on. I could have avoided ordering the refrigerant and overcharging the system. And I mean, when I look at this, I go, that has got to be leaking, right? Someone beat the hell out of that stub line. But yeah, so I learned a few things today. First, these little kits are pretty universal. For this is like a 1/7 or 1/8 horsepower little compressor. 2, if it's not turning on, do your electrical diagnosis before you just blindly put refrigerant in the damn thing. Diagnostics first, parts later. And yeah. All that said, I've rescued this little thing. I've already got a few refrigerators. I don't know that I need another one, but I might spend 10 minutes cleaning this thing up and offer it up for sale. And if you are a pro appliance repairman and you hate the fact that I used this particular device here, this piercing valve, unfortunately, I have not yet got my acetylene rig filled. I did buy a torch. I don't have it filled, and I'm waiting on the new service valves that I can just install right here. So I just did the best I could to get it going. I've not had any trouble with these leaking. If you close that central valve after you're done using it, right? Don't leave that set screw open, because then the only thing keeping that sealed is the rubber gasket on the cap there. Go ahead and close it, and that little needle valve will go ahead and close the tiny hole it pierced in the tubing, and then you have that gasket as a backup. And I've never had any trouble with it leaking. Come back after about 30 or 40 minutes of it running, check to make sure that all the screws that are clamping it down are tight, and you should be good to go. All right, we can see now here, if we can avoid the glare, right, we're about 1.13 amps, and I've got a little bit more frost here, and so I'm probably gonna add a little bit more refrigerant, but I'm not gonna take up any more time. Yeah, any questions or comments that are not obvious, I'd love to hear it and I'd love to learn.